Hello everyone. Today I'll be teaching you guys the Bernoulli's equation for differential equation. So it is kind of a special kind of linear equation where you have to convert dy by dx plus py equals to q to the power y by n into a linear form. So here the following is the general term or the general equation for a Bernoulli's equation. So the pattern to solve a Bernoulli's equation or the steps to convert it into a linear equation is to let any variable or any function, let's say v, be y to the power whatever this is 1 minus n. So if this was 2, 3 or 4, we will simply do y to the power 1 minus 2, 3 or 4 respectively. So here then we will take a derivative. So this becomes dv by dx. So we'll take a derivative with respect to dx, and will this, well, this will come first, then the power will be reduced by 1. So 1 minus n minus 1, the 1's cancel, giving y to the power minus n, dy by dx. Now what we do here is substitute these values in here. But before that, the main step is to realize that whatever the coefficient of the dy by dx is, we have to multiply to the original equation. So here we multiply 1 by 1 minus n y to the power minus n on the first equation. So now first it becomes 1 minus n y to the power minus n dy by dx plus 1 minus n p. Well, we have y. We can write it as y to the power 1. If we multiply 1 and 1 y to the power minus n, it becomes y to the power 1 minus n equals to q. Y to the power n into y to the power minus n, that's just 1, so just q. And here we have y to the power 1 minus n, which we had let as v. And this whole thing here, this is just dv by dx. So this becomes dv by dx plus 1 minus n to pv equals to q. Now here this will be in the linear form with respect to v and x. So the linear form here is dy by dx plus py equals to q. This is the general linear form. But instead of y, we have v. And this whole thing is the function, and we take the integrating factor as e to the power 1 minus n p dx, multiply, and we solve it, and at the last step we just substitute in v to y to the power 1 minus n. So let's solve some questions. So here we have y square. So what we do is let v equals to y to the power 1 minus whatever that power is, so 2. That means v is equals to y to the power minus 1, and we just differentiate both sides with respect to dx. Now y to the power minus 1 is just 1 by y. If we differentiate this, this becomes, well, let's just do it easily. Y to the power 1, its derivative, the power comes first, and the power reduces by 1. So this overall is just minus y to the power minus 2. And using the chain rule, dy by dx. Now here the coefficient is minus y to the power minus 2. So let's just multiply that here. So if we do that, this becomes, well, y to the power minus 2 dy by dx plus, well, it will be minus y to the power 1 minus 2, which is y to the power minus 1, equals to x minus x. So here this whole part is dv by dx minus this is just v, which equals to minus x. Now here this is in the linear form, and here p for the py part or the pv part is just 1. So the integrating factor is equals to e to the power minus dx, because here we have minus, so it's plus to the into minus 1. So here it's just e to the power minus x. So let's multiply this by e to the power minus x. So what we'll get is e to the power minus x dv by dx minus e to the power minus x v is equals to minus x e to the power minus x. So here this will always be in the derivative form of e to the power minus x v, or whatever you multiply with the integrating factor, it will be the derivative of the integrating factor into the function, the derivative function. So here in this case it's v. So this will be equals to minus x e to the power minus x. So what we'll have to do now is integrate both sides. The derivative integration cancels. We have e to the power minus x v equals to, well, what's the integration of x to the power x into e to the power minus x? Well, let's use the di method to solve it. So here di plus minus plus. Let's derivative x and the derivative minus x and integrate e to the power minus x. So here the derivative of minus 1x is minus 1, then 0. Then e to the power minus x, that's minus e to the power minus x, then again e to the power minus x. So the answer will be this multiplied plus this multiplied. So this will be equals to x e to the power minus x minus e to the power minus x. Yep. Oh, sorry. I forgot there's also a minus here. So it becomes minus into minus, it becomes plus. So this is just x e to the power minus x plus e to the power minus x plus c. Now we can let we can let v equals to y to the power minus 1. So overall this is e to the power minus x, y to the power minus 1 equals to x e to the power minus x plus e to the power minus x plus c. Now of course you can just divide everybody by e to the power minus x, so that would make the equation very easy. So the general solution is 1 by y equals to x plus 1 plus c into c divided by e to the power minus x is a c e to the power x. This is the required answer. You can also multiply this on here, and yes, but you can leave it at this. This is fine. So let's do another question involving trigonometry. Now let v equals to y. Well, here this is q y to the power 3. So q is the function of x here. So this 1 minus 3, the power is 3 here. So that means v equals to y to the power minus 2. Now let's just do the derivative directly. The minus 2 comes first. This will be minus y to the power minus 3 dy by dx. Now let's just multiply the coefficient with the original equation. So we'll get minus 2 y to the power minus 3 dy by dx plus minus 2 y to the power, this is 1. So 1 minus 3 minus 2 10x equals to minus sec x, 2 sec x. So here we can just substitute in the values. So this is 2 v 10x equals to, well, just minus 2 sec x. Now here the integrating factor I have is well